kind of marrying of all these different topics and like seeing all these folks in person, both people I've met on the internet in real life. It's a super energizing place to be.
Well, this is actually my first time at Universe. It has been awesome. Not only the event and how it looks and feels, but the people and the energy, like everybody's really excited to do really nerdy things. And that's kind of my favorite thing.
The community is really great. There's all different types of people. Everyone obviously really loves the GitHub platform. And we're all here for essentially just making ourselves better and more productive.
I came here, I got open source, and I got a fresh new deck. I'm loving it. It's great. It's fantastic.
The conversation, the number of different topics that you can talk to people about. We literally just had a question and we're talking to some of the GitHub experts about it and solved a problem we've been working on.
Seeing the vibrancy of the community, the colors, even just how things are portrayed and the little gifts that have a programmable name tag. I love all these quirky little things. It speaks to the community of just how nerdy, but also fun and interactive. And I think it's a really just cool vibe to be around.
I've spoken at many conferences at this point, and most of them are more corporate driven and quite a bit just louder, frankly. But here I've made friends with many people. Everyone feels approachable, and I feel approachable too, and I've really enjoyed that experience so far.
I've always been interested in contributing to open source projects. What's a good way to get started? Love that question because there's so many good ways to get started. You could get started by just helping triage issues. So many open source projects have issues where the maintainers, they don't know if it's a real bug or not. A lot of repositories also have what are called good first issues. Home Assistant is this cool open source org. In Home Assistant, look at that. They have 2.9K issues. Do you see that? They have so many labels. That's amazing. Good first issue. Aha! They've already got some here where it's like, this is a good first issue for you to take on and fix. And also generally just thinking, what are some projects that I use, that I care about, that I might be able to help with?
Hello, friends. Welcome to Open Source Friday. I'm Kadesha, your host for today, and I'm so happy you're here with me. This is our second Open Source Friday stream of the day. We had a really special one earlier. They're all special, but we had just an additional stream earlier with the Julia team. To talk about Julia, why they built it, how they built it, what they see about the future, and so on. So make sure you check that one out. But today we have the maintainer of Simulacrum with us to talk to us about acceptance testing, high fidelity application previews, and fun stuff like that. So I'm going to pop on Jacob. Hi, Jacob. Welcome to the stream.
Thanks for having me. Glad to be here.
Yeah. How are you doing? How has it been? How was your week?
Doing good. It's been a busy week. I have been through part of the week practicing some TDD. That is talk driven development.
Oh.
So I have a nice little prize that we can get to at the end there with Simulacrum. So I'm excited.
Oh, nice. I love that talk-driven development. Very, very good. So before we dive into Simulacrum right now, tell us about Jacob. Who are you? What do you do? And how did you get into open source?
Oh, it's like many, it's probably a story. I've been into computers for quite some time. I actually went to school for engineering, not computer engineering, but structural engineering. So I went to school to make buildings stand up. Did the whole thing, got the degree,
Nice.
got licensed. I did that for years. But all throughout that time, I was doing programming, and open source as just a thing that I enjoyed. And even at work, I started writing code to help make my job easier, make my job faster.
Oh, nice.
So I made the official switch and became a software engineer a handful of years ago. Actually, it's been a lot now. But I started doing open source probably 10, 15 years ago. I'm part of some bigger projects, some smaller projects. I've been working with the Tory project for near the beginning. That's a rather large project. But as part of Frontside, company I'm currently employed with, we have a handful of open source packages, one of which is Simulacrum.
Nice, nice. So tell us what inspired the creation of Simulacrum? Like what problem were you trying to solve when this was built?
Again, long story. I think, and some of this is before my time. I think the development of Simulacrum as a concept started something like 8-10 years ago, maybe. So the idea is when you're working with code, and you need to reach out to some endpoint, get some data. There's many ways you can do that, but we've found that the best way to mimic or simulate that data is through the communications layer, because that's already a natural abstraction. So this idea was sort of born from the need of working with Bluetooth. So they were working with a client. It was something like 8 or 10 years ago, and they had an app. They needed to deal with Bluetooth connectivity issues. Back then, it was much worse than it is now. So they actually simulated a Bluetooth connection and an endpoint. So they're actually able to go through, test all their app code using this Bluetooth simulator, and test all of those cases that are much more difficult to test if you're just trying to use like a real device. And especially with something like apps and devices, giving everybody multiple apps to test Bluetooth with doesn't scale very well.
Nice.
So that's come around into over a few phases now. We've sort of kept the same concept, simulated the transport layer, and we've over time, especially the pieces of code that tend to be more generic and would be more widely applicable, those end up getting open sourced, presuming our client's okay with it. I think the Bluetooth simulator never made it that far, but we have a few other packages that are interesting, some of which we'll talk about today.
Oh, interesting. And does it run offline or?
It's at its very base, it's Express.js. You can run it locally, you can stand it up. The important bit is that there's nothing entirely special about it. It's a tool set that gives you a quick way to get into it and incrementally build up and gain value from it. But the fact that I say nothing special, like it's a good thing, and that's because there's very little caveats, because it's the same thing that you would potentially deploy to production.
Nice.
So we can do things that feel very much like a production code base, but just fake the pieces that we need to, or do little hacks that we need to make it testable and usable for this specific use case.
Right. Interesting. So I guess let's take a look at it, and then I could ask some more questions.
Yeah. So we'll start. There's a few packages. I'll end up going through the examples in the repo if you're interested in following along. Folks on chat, that is. The GitHub API simulator and the Auth0 simulator put two potential like end cases that we could reach to. So those are more advanced versions. They're packages that are used by many folks, not just our clients. So we were able to open source those. But both of those are built on the Foundation simulator. So we'll go ahead and look at a couple of examples here. We've got a let's open up the code first. At its very base, we try to make it easy to start up, get something going, get data there, get you into actually working with it. Because the intent and sort of the competition, as you were, is if you're designing a front end and you need data to render your list of to-dos, say, one way to do that would be write an array, then just render to the array. But you're not going through the same motions, and then you would have to come back and refactor it once the API endpoint exists, and you have to do fetch calls, etc., etc. Same way, like in tests, if you might write a mock, you would mock a fetch endpoint and return a specific set of data. So we want to make it easy enough to start up as that sort of situation. So like the base level implementation of what you might use a simulation or a simulator for would be to just serve some JSON files. So in this case, we have a very simple JSON file, and we say serve all the files at this route. And what that will do is it will, when you start up your simulator, basically return this JSON as a GET request. So if we go ahead and let's go to, that is very zoomed in. So if we go to the foundation simulator and we do npm run, we have let's do the simple start. So we'll do start simple. So that started up our simulator. It's basically just returning all of these chunks of JSON. At the moment, it's just the one. So if we then go to localhost, looks like we're at 9090. This is our simulator. As a base, the root endpoint of the simulator is just sort of like a log or a status page, as it were. You'll get very simple logs. Every time you refresh this page, you'll see our browser's hitting it. And then we can go to this route. This is the JSON file that we're serving. And you can see it show up in our log. So at very base, throw a couple lines of code, throw a JSON file in a folder, and you have a working set of simulation. And then
Nice.
You can kind of incrementally build on top of that.
Nice. So I know you're in the Simulacrum repository, right?
Yes.
So
Yes.
outside, like in our own projects, do we install it by npm or how do we use it?
Yep.
our
We've
own?
got it published as a package. So you can, it would look something, oh, I don't have an import statement there. Well, I don't have an import statement in my JS, but it would just be something like import create foundation simulation server from at Simulacrum slash foundation simulator. So it's published as a package. We've got a changelog. All of our changes get an entry in the changelog. So as things change over time, typical open source rules, as it were.
Nice.
But these are, I am specifically just importing from the source directory for these examples.
Yeah.
So if you want to copy and paste this, you need to swap out the import statement.
Yeah. That's what I noticed, and I'm just like, oh, okay. How do we? Is it like a node or yeah? Awesome. So what kinds of systems or APIs can Simulacrum simulate? Is it just like all systems, all APIs?
Effectively, and that's because it's at the very base Express.js with a bunch of helpers on top of it. So we can just serve JSON. Sort of the next step up from there would be this looks a little bit more like a server. You have some handlers. You're returning data. You can write some actions and define a schema. So one of the helpers that we have as part of Simulacrum is like an in-memory data store. And it under the hood it ends up using immer.js. So it's an immutable data store. So we can actually we can dump whatever data we want to in the Simulacrum store at the start, and then we can mutate it over time as much as we want. So that's sort of that like high fidelity. It's going to feel pretty close to what it would be like when you're working directly with a database and an actual API. But one of the things that we really push on when we're working with clients is the relying on and using your tools to help you. So when you're talking with, if you're a front end developer or a full stack developer and you're hitting other APIs, you're talking to those other teams. And those other teams have code that they're writing, and that contract between you is can show up in a few different ways, and one of which is open API schema. That just seems to be pretty common with our clients. So we have a couple helpers in here that let you do dump in an open API schema, and then use that open API schema to do your routes and your handlers. So instead of writing like raw Express.js routes, you're now using handlers built off the top of the open API spec. And the reason this ends up being nice is that you can then use that open API spec to validate the responses. And that's where we come in to use your tools to help you ensure that that contract continues to be adhered to. So if they change the open API spec, you want your tools to tell you exactly what code you need to change.
Right.
And so you're working with like in-memory data store, very generic routes, and you can continue to build it up. If we look at this one, I've actually, in the extensive server, I've abstracted out all of the helper pieces because they're starting to get big. And you see, like in this case, we have 2 open API specs, and that's because when you're writing code and you're working with an API, that API might not actually be ready, or their open API spec might not be actually in a very good state. So by allowing multiple open API docs and merging them together, we can, folks working on the front end can ship code that uses real API, simulated API endpoints, and they can ship that code 2, 3, 4 months before the backend even gets that route in place.
Interesting.
But if you look through here, more routes, more advanced, still pretty basic REST as a word though.
So why would someone use Simulacrum over like traditional mocking or stubbing tools?
So and I think this will start to get more apparent as we work into the like GitHub API simulator and the Auth0 simulator. The fact that we're building on sort of very common tools means you can do whatever you want with it. You could write a server that accepts WebSockets. I've had teams use Simulacrum to, AI is all the rage, but at the base of it, you're writing an API that makes a call, and it just uses HTTP WebSockets or streaming. It's all the same protocols. It's just a little bit different than folks are used to because it's not a single once and back. I've had teams spin up and make a simulated, like, effectively like open API simulator. The Auth0 simulator actually generates JWTs. We're going through very similar steps to generate the actual tokens and basically trick any system using it into thinking it's something like a real auth. So keeping that, like building on these existing tools and keeping your simulators as close to production as possible means that you don't have to modify your code. So the code you're shipping to production, you want that code to basically be untouched. What you're testing, all those code paths, you want the same code paths tested in CI and locally as are run in production.
Interesting. That makes a lot of sense.
So it's basically avoiding any of those caveats. And then sort of the natural evolution of that means that this works with front-end code, and this works with back-end code.
Right.
I've had folks write Electron apps or Tori apps that hit simulated endpoints.
Wow, even Electron.
It's an API call.
Right. That's true.
It seems like at the outset we said make this abstraction at the protocol layer, and it seems like a very simple idea, everybody's kind of already used to it. But like when you really dive into it, like that becomes a really
Yeah.
powerful concept.
Interesting. So
Because you
how
can have
easy?
like anything.
No,
hit
go
it.
ahead.
Mobile
Right.
apps, literally anything.
Because it's all APIs. Yeah.
Yeah.
Mm. Very nice. I love. How did you come up with that architecture? Like, what made you think to do that, or the team?
I mean, I think a lot of it harkened back to the Bluetooth simulator.
Yeah.
Because nothing existed like this, and to do a Bluetooth simulator, doing that abstraction like at the protocol layer sort of naturally made sense. But as we like continue to use this concept and continue to like build on top of simulators, it was sort of a choice that we fell into and has proven like incredibly useful to build on.
Yeah. So tell us about the building, right? So how easy is it to write our own custom simulators?
So the again, you can start. I usually recommend starting with like the single file server. We have an open API spec, and we've handled a couple routes. If you're working with some front end code and you need to start to work your way into getting more high fidelity testing in place, this can sit aside anything else. It's just an API call. So you can start, like, there's no shame in starting with a single JSON file. Put a JSON file in here, a little bit of code, start this up next to your, your Playwright tests can hit this. Playwright can start up web servers for you. It's just another web server. Start it up, get an endpoint, start getting data. And then you can kind of like incrementally build on top of it. If you have an open API spec already, you might be able to jump right into doing open API specs. And then you slowly fill it out. One of the interesting bits about the open API spec is, do we have? So we don't have any examples here. It might be time to jump into the GitHub API simulator.
Yeah, let's do it.
So you like naturally just kind of build up over time. If you need a route for testing, toss some JSON in there, potentially do some more advanced data store type stuff, and eventually that can become something like the GitHub API simulator. This one is a little bit more advanced. You'll see GraphQL in here. It does have a GraphQL server, and it actually does auth too. And it does auth enough to trick every system into thinking it's doing auth, but it's actually really not. Yeah. So when you're going through an authentication flow, there's usually multiple like handshakes back and forth. If you're, in most cases, what you end up needing to do when you talk to the GitHub API is get a token and then use that token in your requests. So if somebody's code is hitting the GitHub API simulator, we can make a token and it can look like whatever we want it to, because they're going to come back and immediately call our API and we just handle the token however we want to. So as long as we fake enough of the auth that the system that is under test thinks it's real auth, it will just proceed as normal.
Interesting.
So let's pull out some of these little bits here. So the extend API, that sort of drops you into very, very basic Express.js routes. So router.get is an Express.js route. So you'll see this is our auth. We have two routes that are handled. These are our tokens. When we're verifying the tokens, we can make the tokens whatever we want them to be. So we can like basically trick the system into going down production code paths without actually having to do much of the work potentially.
Yeah.
So then building up from there, we have this GraphQL endpoint, and then we have all the handlers for that. And this starts to get into more complex setups, but we're building on top of existing open source. Create Yoga is a GraphQL server that, like it's a production GraphQL server that works with Express.js, and it can hook right into Express.js. So we drop that in, we give it a schema, and we feed it data using the resolvers. If you've ever worked with GraphQL, feed the data through the resolvers, and anything using it thinks this is like a real endpoint. And there is, again, all of this ends up being incremental. We don't have every GraphQL route handled.
Okay.
So there's routes that we've found common enough that we've worked with clients, and they all seem to use these and end up showing up here.
Yeah. Can you run the GitHub API simulator so we see what it
yes,
kind of looks
and
like?
This is that's actually a great segue, because we get into the next piece of it. So the fact that we're building on top of an open API spec means that we get some of the other niceties from that. And the GitHub Open API spec is large, but in a good way. Different part. The GitHub API is a little bit more, I don't know if I would call it unique, but the base route actually returns some information. So if you go to the base route, it's not going to be your status page. So we do take an arg in the foundation simulator to change the page. So in the GitHub API simulator, if you go to simulation, this is our status page. But the fact that we're building off of an open API spec means we have literally the whole GitHub API
right
technically simulated. And what ends up being really interesting with that is the GitHub API or Open API spec has examples. So if we don't specifically return a handler for that route, it'll fall back to the actual the example that's in the Open API spec. So if you have a very base requirements for some of these endpoints, technically we have everything simulated. Some of these ones that have like usernames in them are harder to click on, but like if you go to users, this I think is a generic endpoint. Yeah. So this is the data that's actually in the Open API spec from GitHub in their example, the example portion of the Open API spec. So again, it gives you a place where you can like incrementally get into and build up a simulation without having to go through all the work of actually handling all the routes necessarily. There are a few routes that we do have more information, with, because those tend to be the routes that like folks hit and folks want to like see a list of repositories. Or see a repository that's at an owner. So if we look at like our REST endpoints, we have a handful, probably like 15 or so, that we actually have wired up to the simulation data. So if we look at the actual use of the simulator, we take an arg that includes the initial state, and you can give it little bits of information. In the GitHub API simulator, we're using Zod under the hood to Zod and Vicar.js to build up this data. So based on a small chunk of data, we can build it up into a more full-featured chunk of data that would look real. But with this, we get, so like there's an organization front side, and it has a repository test repo. So if we would go to, if we would look at our routes, we could look at like, what would be a good one? Installations. Installations are for GitHub apps. So this is one of the cases that being able to test is really helpful. If you have a GitHub app and you're running a backend and you're working with APIs using the GitHub app, being able to test it is very difficult unless you have something like this. So here we can go to, well, actually, we'll do it in the browser. org/frontside/repos. Localhost 3300/org/frontside/repos. And these are, in this case, we only have one repo for this owner.
Mhm.
But you can see we have a lot more data here than we had given to it to start it up. So if you're building front end or back end or any code that you have to hit APIs and you're needing something like this, having a contract through an open API spec, having a contract defined through a ZOD schema, you can use those tools to build up chunks of data and have those tools tell you or warn you if that schema changes. So having one source of truth, making sure that this stays up to date is important, because it's one thing to like spin it up and get it started. It's a whole other thing to continue to maintain it.
Right. Are we also able to model like rate limits and error states?
Yeah, we could. And actually error states is a really good point. Because a common question that I hear is if you're using a simulator, what's the benefit of doing that instead of just running a service? And there is some, like, at some point running all the services locally becomes a lot. If you have 10 Java services, that's going to bog your computer down. This is a little bit more lightweight, but I think one of the big benefits of being able to write the code however you want is we can have whatever logic we want, single line, couple lines of code in JavaScript, and return whatever response we want. So we can actually pipe data in that is specifically intended to fail, which ends up making tests. And this kind of comes back to the high fidelity tests.
Yeah.
One of the things that are very difficult to test with and hitting real APIs is getting your data into a specific state. Because the system intentionally is made to make sure you don't get it into a bad state, but it can happen and you want to be able to guard against it. So in the front end, being able to handle 403s or 401s or 404s or 500s and potentially handle those differently. Being able to say, well, if this piece of data says return this code, do that. If you hit something that doesn't have a value, just return a 404. So I think that's probably one of the biggest benefits of being able to build up this platform, is because you can get. I actually had with a client end of last week, they had one of their APIs, a whole system changed beneath them, and they didn't know about it until everything started breaking. And unfortunately, all the errors they were getting were object.
Classic.
Classic, right? So they hopped in, figured out, kind of like zoned in where the issue was. They put in a fix, but they weren't sure of it because they had no real idea of what the actual error was. So we were actually able to. It did resolve the issue enough, but we were able to, with simulation, go back and actually recreate those situations.
Nice.
So we could put the data into the actually a bad state or return a specific error code and see why that was actually returning an object. And it turned out that what was happening was the situation that was throwing an error, it threw an error as an object, and it was the try catch that was further up the stack was just expecting strings.
Nice.
So, but now we were able to actually go back through, figure out what happened, why it happened, and it actually feel good about our about our fix.
Nice. Okay.
And
cool. Because I was gonna ask you, if you have any examples, but that's a really good example. Yeah.
I think that's the crux of testing is when you talk to folks about doing like coverage metrics, nobody ever says get 100%. There's the 80-20 get 80% of the test covered kind of thing. And that's because you want to have a good ratio between value and effort. And that then the result of that should be a confidence boost. You want to feel good about and understand and de-risk deploying. So if your tests lead you to do that, that's a good test. If you're just writing tests to fill a metric, then it's sort of skirting the actual value of writing the test. So
Yeah.
being able to put things in a bad state or into a good state, or potentially like generating 100,000 records and seeing how your system responds to that. Like paging on the front end.
So are there different modes in the simulator? For example, like I was looking at the documentation, and is there an enterprise mode? How is that different from like the regular?
Is there an like GitHub Enterprise?
Yeah.
There are technically two different schemas. They're very similar. I believe one of the inputs to the GitHub API simulator is, where's my example? Oh, here it is. If we look at the inputs here, you can give it an API URL and API schema. So in the case of a specific special schema, if you have an older GitHub Enterprise instance, you can potentially give it a schema. Or you can, one of the big differences of the enterprise GitHub to github.com is different URLs. So you can give it a different API URL to mimic the use case of GitHub Enterprise. And that's where most of our clients have actually been using this, is in an enterprise instance, because it's, there's those differences. So that means there's less tools that potentially support GitHub Enterprise. But then on top of that, you end up running into more security rules. Like you potentially can't actually create a repository unless you go through like 17 layers of security. So being able to do whatever you want here and put it into whatever state you want, potentially bad states that they don't want to exist in the real production GitHub instance, you can do whatever you want.
Interesting. Someone asked if you know if of a Claude AI chat simulator. Could Simulacrum be used for that?
Like I said, I had a client do a chat simulator, but that did not make it out of proprietary code. So I don't have anything to link to, or that I know of, that folks have made. But you could certainly, we've done it already.
Yeah. Cool.
And that for the most part, like the chat interfaces are going to be some sort of like WebSocket or potentially like server sent event type thing. So it's another protocol and a couple packages, and you can handle that.
Gotcha. We have a comment here. Some say never decrease coverage, though that can be a bit tricky when you hit 95%.
Yes.
Of course, talking about code coverage here, not feature or scenario coverage. That is a bit more useful, in my opinion.
Yes, and that's a very good point. I was using code coverage not as a suggestion, but as a situation that folks might find themselves in. And the benefit, like you alluded to, the benefit of going from 95 to 100, or trying to prevent yourself from going less than 95, folks just write whatever tests they need to do to keep the number whatever it is.
Yeah.
And then you've moved outside the value of actually writing the test.
Okay, so for people who are new to Simulacrum, which is most everyone watching, what's the simplest first simulation to build confidence quickly using this tool?
I would say grab one of the examples. We were actually just talking about this the other day, that we should add a little CLI to dump something like this, do like a Simulacrum/new or something like that, or Simulacrum new. TBD. I guess I need another talk to do some more TBD. But the easiest way to get started would be copy something like this. You'll have to replace the import, obviously, and then drop a JSON file in there, and you'll be off to the races. All of my examples here are in part based off of things that I've done with clients, and they are all also used in the tests. So I feel pretty confident that you can copy an example and it'll work.
Cool beans. And how can folks contribute to the repository? What type of help are you needing?
I think like Auth0 is one that folks have been contributing to. That one's probably been open source the longest out of all of these. And an example of contributions that have happened in Auth0, it's incrementally building it up, and Auth0 is also changing over time. So some of it is maintenance or feature development, some of it is feature development, but some of it is also maintenance just to keep up with the Auth0 API changes. And it's the same situation as you would have with any other system like this, mocking or whatnot. But the benefit here is that we're sharing that work. So if one person adds a management API in Auth0, now everybody can use it. So if you're using one of these simulators, or you have use cases that potentially feel like it would make sense to have an open source thing, feel free to open up an issue. We've got a Discord too. Feel free to hop into the Discord and say hi and ask questions there, and we can discuss. I've made probably 4 different auth simulators at this point, and they all seem to be a little custom. There's this little custom bits. They have their own like custom grant types or whatnot. And the clients that we tend to work with, especially recently, we've been working with an open source community called Backstage. It's an internal developer platform put out by Spotify.
Okay.
And that ends up being a really natural fit for this use case, because Backstage is literally intended to be a mesh. Bring in data from a whole bunch of sources, mesh it all together into a platform that, like an AWS dashboard in some ways. See all of your running systems, see all of your, people in the company, et cetera, et cetera. So I've had clients have double-digit custom simulators for all of their different APIs.
Wow.
Because at some point it's just impossible to handle and impossible to test if you don't have a way to actually like manage all these different APIs.
Yeah. It's like scalable testing for enterprises, huh?
Yeah. And this is all, it's a server. We run these against Playwright tests. We run these in CI.
I was just going to ask, yeah.
Yeah. You start it up like a server, it runs on the side, and, it works, pending any weird networking issues, it works effectively the same locally as it does in CI.
Yeah.
And you can use this as a tool that you hit like your Playwright tests can hit this, but you can also just use it for like a local dev. So again, harking back to that, I need to render a list of to-dos. I'm going to start with an array.
Yeah.
A way to, upscale that a little bit would be to spin up a simulator quick, return an array of data, and now you can get all the way through to implementing the whole fetch, the whole fetch sequence in that.
Nice. So then can multiple simulators run together in the same environment?
Yes.
You mentioned CI? Yeah.
And this is, there's actually another question. Do you have an environment like the Postman?
Yeah, I saw that one.
But Postman is doing, and all these are kind of doing something similar in some ways. That's a little bit more of an app, and this is the way we set this up is it's kind of intended to live with your code, because as your code changes over time and as it needs to integrate with APIs, having it next to your code is really helpful, and being able to change it as your code develops is really helpful. So there's like we don't have an app. The closest that we have is these status pages. But back to the thought of multiple simulators. This starts to come back to what I was alluding to when we started.
Yeah.
I have an example that I just cooked up. Pingback. So what we end up happening, what ends up happening usually with our clients is we end up having multiple simulators. And like I had mentioned, I've now made multiple identity services. So sometimes that looks like an overall gateway that all of our routing goes through. And that gateway is the thing that sets the token. Sometimes that looks like something more similar to Auth0, where you're actually hitting that API, asking for JWT, using that JWT to then get access tokens. So there's this sort of natural interaction between these systems then, because those users then are potentially users that show up and would need to potentially deal with permissions in other systems. So one way to do that, again, it's all just HTTP endpoints. You can have, and actually in the case of the identity simulator I was talking about, you can have whatever route you want. So we put actually a special simulation route because in our situation, they were trying to, with their front end, generate a bunch of access tokens.
Right.
Code that could potentially be refactored, but we wanted to be able to understand it better. So what we did is we, in our playwright tests, we actually generated cookies through a simulated special endpoint in our identity simulator. We made a call out to that. It gave us JWTs, and then we were able to pipe it into a cookie in our playwright test. So then we could skip the whole sign-in loop. So you can do whatever you want with these like special routes, or you can just use public APIs. So what we have here, let's close you and save you, because I need to remember to submit that. We have server 1 and we have server 2. Let's make our code a little bit bigger here. And actually at the moment, these are two files that are pretty nearly the same. The big difference is the ports are different. And the reason I call it pingback is because the feature that I was just working through was webhooks. And that's something that not many systems that try to simulate data are able to handle.
Right.
But really, it's just a fetch call. Again, transport layers. So as long as we have a way for the user to like spin up and define what to do with the webhook, we can make whatever call we want to. And so in this case, what we have is we have 3 endpoints. We have an event boop, we have an external boop, and then we have a get boop.
Oh, great. These names get me. Pingback boop.
So what we can do is event boop is a post, and that increments. Our get here is it accepts. So this is sort of the way that I've been kicking it off. And basically, if somebody lands on this route, it kicks off or triggers the webhook. We can also, I haven't gotten to an example for it yet, but you can also set up generic tasks. So you can listen to like the internal simulated database for changes. So you can write a webhook that will fire off anytime, a new user has added. So you can make it feel very real. And then by the fact of having webhooks, it means that these simulators can sort of naturally, or even when data changes, start communicating directly with each other. So situations that we run into is, especially in deep integrations with the GitHub API, they might hit an API. That API creates a new repository in GitHub.
Mm-hmm.
And then that new repository ends up coming back and showing up in that API's data. But then we also get a webhook from GitHub directly. And now you need to make sure that all those states are like in sync. So being able to not only directly communicate over normal transport layers to simulators, but have the simulators actually talk to each other,
Right.
ends up being a really powerful concept.
Yeah, that's like a huge differentiator too.
So we can give it a quick try here. If we gotta start running stuff first. So let's go to our foundation simulator. And we're going to do npm run, start pingback. I'm going to do the watch one. The watch is we're using very basic node scripts or node commands to start this, and it
Mm,
as of version 20, it has a watch command, which is super helpful.
nice.
You can actually see it here. Yeah, it's got
Yeah.
the watch path. So unless you're doing things that are more complex, you don't actually need something like other libraries that are out there. So this script started out both of our simulators up, and we can do I think I still have some calls in here. Let's do a call to 3051 external boop. That came back okay. So what we're seeing is the status okay, like on line 55.
Mm-hmm.
And then I've got some logs. So we can trace this through using these logs here. Firing webhook from port 3051 to 3050. So we hit this endpoint on line 50. It fired off this webhook trigger. This webhook
Nice.
trigger goes to localhost 3050. And we're seeing the webhook trigger is where it's firing. So actually, technically, now we're in the other one. But that ends up showing up in the boop trigger where we're seeing this firing webhook. So we're seeing the one here. So we're seeing firing webhook from 3051 to 3050.
Very
That makes
cool.
the actual call out, and then we see the response back with the context.
Very
We
cool.
See that it went correctly, and then we can check so that the ultimate resolution of this is it making a call to event boop at 3050, which will increment our boop counter. So now if we make a call to our boop counter on 3050, we see count as 1. And then we can see the, again, the code is pretty much the same. So we also have a boop counter in 3051, which has not been incremented because these are talking to each other. So you can, and actually the return of a create foundation simulator gives you the store. So you can either sort of use a back channel, like use the store directly, and sort of like private API it, or you can just use public APIs. It's just an API call.
Nice.
And this
Love
is
it.
all runnable in Node. So most of the work
Yeah.
that we do ends up being, fetch is available as a global now.
Yeah.
The amount of code you have to write ends up being very little with a little bit of helper code.
Yeah, that's really cool. And so like this triggers one more question, and then I have one more question after that. And then we can wrap up. So how is authentication and state persistence handled by Simulacrum?
So under the hood, again, it's immer.js, which is an immutable
Yeah.
data store. So every time you restart the simulator, it'll clear out that data. There's ways you can do to like persist it if you want. You may opt to like pipe in initial state. And that initial state can give you like a base set of users. So if we look at like the Auth0 simulator, and I think it's at the store, we have a default user. So if when you're starting it up, if you don't give it a user, it'll just use the default user.
Yeah.
Or you can give it a user as you start it up, and or many users, and they'll be available every time you start that up. So it's nice because you don't have to worry about accidentally breaking something. You can do whatever you want and put things in as bad of a state as you want. And if you really muck something up, you restart it.
Yeah. Is there documentation that tells us how to set all this up for Simulacrum?
There's we've got some information in the READMEs. So each of these packages does have a README. The READMEs are always kind of an ongoing effort.
Yep.
So I would say a combination of the examples and the READMEs are going to be, what really pulls you along. Or again, feel free to hop in our Discord, ask any questions. I've been working with the idea of Simulacrum and these simulators specifically for years now. So
Yeah.
like I can answer these questions in my sleep.
Yeah. Awesome. Please, not please, but great project. Thanks for coming on and showing it to us. I guess the last question I have is what's on the roadmap for Simulacrum, if anything?
I mean, you saw that the near term thing, getting the webhooks in place was sort of a big it was something that we had architected for like 2 or 3 years ago, but until recently I haven't hit like a really concrete use case for it. But now we're doing a lot of event testing, so it's going to end up being useful for us. The other big push is we had sort of in a previous phase. We had set things up where you would start a main server and that would start up all your simulators. But we found, especially with like the Auth0 simulators, folks just wanted one single simulator. They wanted it started up as fast as you can get it started up. So we sort of like refocused efforts into being able to like get into it really quickly.
Nice.
But especially when you start getting into having multiple simulators and multiple simulators working in concert with each other, having a service that can start all of them up, handle some of that networking, and give observability around that is going to be really beneficial. So we've sort of refocused this package into. Do we have? I think we got a test in here. We've refocused this into a helper to like start scripts up at the moment. So you can give it very much in line with, conceptually, this is sort of like a Kubernetes control plane. You want it to be able to start things up and give you visibility into what's happening like throughout all your simulators. So for this first step is starting the thing up and some wellness checks to ensure that it actually started up correctly. So the next things coming down the road are likely going to be more helpers around this idea and being able to give greater visibility into what the simulator's like existing state is and how they're changing over time.
Nice. Very cool, Jacob. Very cool. Folks, be sure to go check out Simulacrum. I dropped the link in the chat multiple times, and I'll pop it on the screen again. Go contribute, update the documentation. Tell us how to set it up in the docs. That's like a really good way to contribute to documentation. If you have questions, check out the Discord server. And thanks for joining Open Source Friday. I think that's all we have today, right, Jacob? Unless there's anything else you wanted to say.
Yeah. If you have any questions, feel free to reach out. All of my socials are on my website, jacobbolda.com. Or you can sneak through the Simulacrum package and see all my socials on connected to GitHub. So I'm
Nice.
looking forward to talking with folks. It's a lovely project to build on top of.
Nice. Thanks for watching, folks, and we will see you next week. Bye.
Bye.